Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 139, length of the longest increasing path. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. So this one I think I end up solving pretty quickly. Most of the time was spent on Q3, not Q4. I honestly, I had two wrong answers because I was just sloppy and speeding this up. So the first thing to notice for this particular problem is that n is 10 to the 5th. And that is too big to be n squared dynamic programming. I know that may be my first thought too, is the n squared dynamic programming. Another complication for this problem is that there is this thing, right? It has to contain this coordinate n sub k, coordinate sub k. Took me a little bit of a think, but not that bad. Basically, you just separate out the way to construct it is that, okay, starting from this point, the longest increasing path for coordinates and the longest decreasing path for the other side, right? So basically you want to, from this point, construct the left and the right, depending on how this video is mirrored, the left and the right, and then together you should have the coordinates, right? So that's basically the idea for this one. But that's just the n square idea. So those are the two things that has to be done, this and dynamic programming. Of course, I'm not going to go over this today just because there are a lot of videos on this already. But longest increasing subsequence is an n log n solution. I am going to use this idea. I'm not going to explain it that well, just because I want to keep this video short. This is a hard problem, so I just want to focus on the other components. This part though, there are multiple Leetcode problems with this, so definitely check those out. Check out those videos, and because the core part about this, and it's kind of tricky to explain in a way, definitive way, for me, in a concise way, not definitive, is that there's a binary search. The idea is this greedy idea of that, okay, you have a number, you want to, another way to think about it is that you have a number, you want to find what is the longest path that you can add this number to. Or, the longest path that you can add this number to. And in a way, you can kind of figure out why it's monotonically increasing, and as a result, you can binary search over it. But so basically, to summarize, LIS for each number, find the longest path that we can and add this number to, and as a result, turns out you can binary search on this to binary search on this n log n solution as a result, right? So so how does that relate to this problem? Well, it turns out this problem is pretty straightforward as a result, but the idea here is that, okay, so now and these coordinates are not in any particular order, so you are able to sort them. So the first idea is that, well, first thing we want to do is we want to filter out the coordinates that are, so we're given one coordinate, right? So given the one coordinate, we can figure out all the stuff that is increasing or larger than this path in the way that is defined in this problem, which is strictly increasing on both dimensions, right? So here, you kind of look at a graph. Actually, I'm going to draw this out. Hang on. So so the thing is that, okay, let's say we have an axis, slightly straighter axis, and we have a point, right? So okay, let's actually make this a point near the middle. So we have this one point, and we have a bunch of other points, right? And then here now the first idea is that we want to filter out to the nodes that we only care about, right? Because then now, here are the nodes that we care about that could be smaller, and here are the nodes that we care about that could be bigger, right? And then now, what happens is that, and I think the way that you can think about it is to kind of construct a few examples of what's increasing, right? Because then now you have, you can, for each, I mean, we should do this for each node, but visually for the definition of what they call increase, for each of these nodes, we also have like a thing, right? So then now, and maybe I needed to, okay. And I'm gonna add some dots real quick. So then now the problem becomes, okay, let's say we connect this node, and then we can't come here, but if we had another node here, we could have also came here maybe, and so forth, right? But you would not come here, and you cannot go down though. I guess this one is go there. So here now, after this visualization, and I mean there are more lines, I just didn't draw them all, just to be clear, right? Is that okay? Now if you are able to go, now with this visualization, right? We know that we want to go from left to right on the. We know that we want to go from left to right on this dimension. Then what does that mean? That means that keep in mind that before we had something like this for each of the thing as a visualization, but then that means that if we are already looking at it from left to right in this direction, then we just kind of need to. That means that all the numbers that we've already passed, meaning in a sweep line kind of way, meaning going from let me change the colors again. From this node to this node as a sweep line kind of thing, that means that all the numbers that we processed are already to the left. So that means that, and that means that all the numbers to the right has to be bigger on the x-axis, right? But so that means that if we kind of re-visualize again the constraint that we care about, which is this thing, that means that we only actually have to care about increasing in the future. And that's basically the idea, right? Is that, yeah, if you sort by x, then now as you do a sweep to do the longest increasing subsequence, you just have to go up to the right. Yeah, go up on the right dimension. And of course you can say that that's basically the core part of the idea, which I was able to get very quickly, because then now this reduces to just going from left to right. It becomes the boilerplate longest increasing subsequence. Someone actually, Joseph on my Discord, actually brought this idea up that I didn't really understood what he meant. But another thing that you can realize is that because of path compression or coordinate compression, if you coordinate, I know that these are in space, but we just kind of coordinate that next to each other so that all the things are next to each other, then now it just becomes a regular longest increasing subsequence because where I is the index of the longest subsequence array in the original case, right? So yeah, so that's basically the visual idea for this problem. And after that, I got two wrong answers because of tie-breaking things that I was just too sloppy, because I was going nuts on Q3 that I didn't check on for this one. I should have. But yeah, but let's go over it really quickly. Yeah, so here for the y coordinates, as we said, we filter out all the stuff that is, strictly on the upper right quadrant, right? And then here we do a binary search, keeping in mind that you have to do a binary search on the bisect left, not bisect right, because if it's equal, then you don't update the bigger one, right? You don't add on to that chain, so that's why. So that's basically the idea here. Keeping in mind that we do sort the coordinates first, so that these coordinates have the right order by the time we construct all the y's, right? And the reason why we have this as x is that, well, the first component is x because it makes sense. But the reason why we want to sort the y component in the other order is because if two numbers have the same x, we want to get the higher ones first. Otherwise, you create a chain of them by accident, right? So bring up the visualization real quick. The reason why we want to sort y is because if you have something like oops, if you have something like this, and this, if you process them in the wrong order, you're gonna go up this way. But if you do the y first in decreasing order, then you're always gonna go this, and then this would never, this this node would never get matched to this one. So that's basically the idea for this. And then for the, so this is for the up to the right, and this is for bottom to the left. I do a thing with, checking that it is smaller, right? The reason why I have negative y is so that I can reverse it and then just do the same thing with binary search. So this code is actually, I think, copy and paste from here as a result. And I just have the left. And remember that in the longest increasing subsequence, the array is actually array sub I actually contains the smallest y that has a length I, right? Or I plus 1, I think. Yeah, I plus 1. The smallest y that has a length I plus 1. So yeah, so that's how we do a binary search. Again, if this doesn't make any sense to you, I apologize, because it builds off the longest increasing subsequence problem, so definitely be familiar with that problem. I think I probably have videos that explain this in more detail, but this is basically, yeah, the idea. But yeah, so in this case we sort, and that's pretty much it, really. I got two wrong answers because I off by one on the bisect right instead of bisect left, and then I forgot to sort the y coordinates. So I don't know, just very sloppy, but because I think I was tilted on the other problem. But yeah, that's all I have for this one. Oh, over the complexity real quickly is that sorting is gonna be n log n. This is gonna be n log n, and this is gonna be n log n. So everything is n log n, and that's it. That's all I have for this one. Let me know what you think. Yeah, thanks for watching, and you can watch me solve a live during a contest next. Solutions. And it's 10 to the 5th is tricky. What is K? Oh, it has to contain this thing. Huh, that's interesting actually. Well, we can't sort it yet. But... oh wait, also we can't sort it at all. I'm just being dumb, but okay. I mean, just n log n sorting thing, but I feel like I could do it, but I'm jumping back and forth. Alright, let's just try. Alright, so the longest thing would have been to binary search on this, and then just go right. And that's the length of the thing. So then we binary binary search from the phone. So what I do? Because the 1D1 would be binary search, and even then I don't even know if I could do it. Oh, do we do sort it? I misread this a little bit, but okay, fine. I mean, that's easy. Let me just do longest increasing from here. And longest decreasing from the other side, right? That's not that bad, in theory. I forget how to do the thing though. I've done this farm before though. I remember doing that. I think I've done this farm like a decade ago. N square is trivial, but once we sort it, then now yeah, okay, then maybe we have something like if x is greater than c of 0. Oh, okay, so then now we have didn't crash. That's what I wanted. That's all I wanted. I probably could have that's not right. Probably could have abstract this, but okay, so it's definitely wrong. So we have 113, so we have to be bigger than 2. This is backwards anyway, so I think the left side is wrong, but I'm overcounting, not undercounting, so. K is equal to 1, I forget that, okay, 2. So why am I doing ones? X, oh, I did the signs wrong. 4, 3, it's slightly better. But still no cigar. Right is 0. So we want something to the left. Okay, yeah. So what says K is 1, so that means that we have no, this should be no, the other one was right. It's 113. Oops. Okay, 113. Oh, I got the longest increasing thing, but we also have to do and y is greater than. Yeah, that's why. Three and 1. 3 is fine. 1 is not fine. I think I have to reverse this. Yeah, I think I have to reverse this. Oh, wait, this would never make sense. Three, 2, alright. YOLO submit. Oh well. I mean, I wasn't super sure, but I also running out of time to solve both, so I'm just trying something quick. The idea should be right, but maybe I'm wrong on this one, huh? So the answer should be 2, but I get 3. So I'm just really wrong. So the index is 0, so 150. Why do I have 3 then? Left. Oh no, they're both right. Oh, huh. I'm not doing the type working. I think I'm mostly right, but I'm not doing the type working. How do I do this? By sorting from the other coordinates first. Okay, so on type working. Okay, fine. So we want something like this. Is that not right? Who am I missing a comma on? Key is equal to lambda. $322. Okay, that's just like a dollar thing, I guess. $322. That is a silly mistake on my part, though. Okay. YOLO submit. Did I not? This is a different wrong answer. Okay, I am just being bad today then. I'm rushing it. Oh, this is the other side. So 7, 8. So they're both smaller, and I put 3. Do I sorted it this way then? They're both smaller. Yeah. Well, let's double check the thing real quick on the left side. I'm just being sloppy. That should not have been 2 wrong answers. -4, -4. Oh wait, no, that's not right. That's just. No, I mean I think we're doing right. Bisect right, right? Is it bisect left? Because if it's the same, we do the same. Okay, yeah, I was wrong on this one. Yeah, bisect left. I thought I needed the next one. I'm thinking too silly. Okay, let's regroup. Let's see. Alright, what do we want? Oh, so 2. Okay, fine. Did I put anything? The silly thing is that I had to 2 wrong answers from the same silliness is kind of bad. That's a 10-minute penalty. But okay, let's go back to this one that I don't know how to do. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and this explanation, this problem, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.